Hello, it's Mr. Leapforth again, along with
Joe.
And we're looking at the 2012 AB Calculus AP exam, question 3. And it looks like this is the problem where you look at a graph of a derivative. F is labeled. And I'm taking the antiderivative of f to get back to g. So this is one of those f's the derivative of g, g is the antiderivative of f type problems. And so you can expect to see something like this on the AP exam for sure. The lower end here is 1, so that's just interesting to note. Now, it says find g at 2, all right? So instead of, there's a formula, right? So instead of doing g at x, you're doing g at 2. So wherever you see an x, you're going to plug in a
2.
So you have the integral from 1 to 2 of f of t dt, and f's over here. So from 1 to 2, so it looks like we're looking at this area in here, which is a triangle, all right? So that graph keeps disappearing, Joe. I can't get it to stay. It seems like the slope here, you're going from 0 to -1, so you're going down 1 and over from 1 to 3, 2. So the slope is every time you go down 1, you're going over 2. So if you're only going over 1, it seems like this is a half. All right, so it's down a half over 1, down a half over 1. So 1/2, down a half over 1, down a half over 1. That makes it down 1 and over 2. So that's correct. So I did a lot of work here to figure out that this was 1/2 and this was 1. And so the area here, I'm going to move this, is equal to 1/2 base, which is 1, times height, which is a half. And so that ends up being 1/4, and since it's below the axis in the correct order, it's -1/4. All right, so for the next part, it's g at -2. So instead of doing from 1 to 2, we're going to go from 1 to -2 of f of t dt. So 1 to -2, check this one out. In red, from 1, so you have this area here, and then you have this area here. All right, so this part here is half a circle. The area of a circle is pi r squared. The radius is 1, so it's 1 squared times pi. What's 1 times 1, or 1 squared?
1.
So that's pi. So this is clearly on the non-calculator part of the test. That's why we're doing some work. And it's below the axis, so that's -pi. And then this is a triangle, so the height is 3. That's 1. So base times height divided by 2 is like 1.5, and that's positive. So you have this positive 1.5 and this -pi, but nobody really likes to count from 1 to -2 because that's backwards. And so when that happens, we flip the sign, and so it's actually -1.5 plus pi. And it's probably how the answer was left for that one. Trying to look at the answer key here. Well, even math teachers don't go through the whole exam. Good thing we had the answer key there, so I was cheating. We'll probably have to knock a point off here. But, Joe, we acted as if this was a whole circle here. And we know that it's only half a circle, so it's pi over 2. And it said -3/2, but they would accept -1.5 for that. So sorry about that. Again, this was a semicircle, so we took the area of a full circle. But, I mean, you only have half of a circle, so we got to divide by 2. So, all right, and there's no units in the problem or anything, so we're good with that. All right, so let's clean up a little bit here. I like the graph. We want to have the graph there. So I wonder what this sounds like to the people at home. But anyways, all right, so a little bit cleaner. We got our graph. It's cleaned up a little bit. And so we want to tackle B here. So we have, we're looking for g prime at -3. And g double prime at -3. This is a standard question. All right, so if you want g prime at -3, well, g prime is f, so you want f at -3, and I'm looking at the graph. So all you have to do, this is -1, this is -2, that's -4. All right, so somewhere in here is a -3, so we want to kind of go up. It's going to be right in the middle. So if this was at 1, this was at 3. We got to think that this here is 2. So it's negative 3, 2, and so our answer there should be 2. And so that is actually our first answer. And so I should have put it next to the place where the first answer goes, which is up here. All right. And so then that's this. Put a big box around it, smiley face, no units or anything for that. And then you want to find g double prime at negative 3. And so basically that's just asking us for this pink slope right here. And so you could do, if you want to be real careful, you can do 3 minus 1 over negative 2 minus negative 4, which is 2 over 2, which is 1. And so that'll be our answer for that second part. Alright, so again we need the graph here, so we're going to clean up the mess here. I'm trying to stay under 15 minutes, so I can still have time to relax and think about the problem, but I still want to move at a particular pace. So horizontal tangent line. Anytime it says horizontal tangent line, you know, you're looking for a place where the derivative, or g prime, which in this case is f, is equal to 0. And you'd like to state that. Alright, you want to say g prime at x equals 0, or f of x equals 0. That'll get you a point on the test. It was given 1 point, so a +1 just for saying that. If you know that there's a horizontal tangent line where the derivative is equal to 0, you're in a good place. So where does that happen? It looks like negative 1 and 1 are the places we want to consider for that. And it says find the x coordinate where it has blah, 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 and then tell us if it's a minimum, maximum, etc. And so that's what we want to look now. So let's take x equals negative 1 as our first choice. Why do we like x equals negative 1? Because g prime at x, or f of x, is equal to 0 there. We have g prime of x changes sign from positive to negative. You probably want to write the full words on the test. And so if it's going from positive to negative, that means increasing to decreasing. So what we have is a relative or local max at x equals negative 1. And so that's good. And then we'll move to our other point, which is x equals 1. Why do we like that point? We have g prime of x, or f of x, is equal to 0. And so we're looking for the change of sign, but you know, g prime is negative before and negative after, so there's no change in sign. So there is no change in sign. So it's not a max or a min. So that's not perfect, but you'd write something like that, and then you'd be good for that problem. And I was trying to keep these videos under 10, so I probably want to go back and, you know, perfect that. You can look at the keys and stuff and see exactly, but I'm trying to get the general point here, so we're cleaning up our mess. You probably don't need to watch me clean up the mess. You can fast forward through that. And then D is our last part. Remember, for these problems, it's not necessarily true that one of the parts is harder than any of the others. Actually, for you guys, when it asks for points of inflection and it gives you a point for the answer, this should be quick. You're just looking for maxes and mins in this derivative graph. So you got 1, 2, 3. So you should be able to say pretty quickly that they happen at x equals negative 2, x equals 0, and x equals 1. You already got a point. This is D, and you already got a point just for having that. You know, why do we like these? Because g double prime of x, points of inflection, are found in the second derivative, which is f prime, and what we have at those points is a change in sign in g double prime of x. So that's what we want to look for that. And that's the explanation that they're accepting for part D. And that's it for that.